Okay, so let's just talk about a transport layer TCP basically. So in previous lecture I talked about IP, right? And there's another important concept in networking, which is a TCP, right? So basically TCP/IP are the two most important concept in networking. So if you want to understand network security, right, the knowing TCP/IP, right, it's essential, right? Without knowing TCP/IP, we cannot really talk about network security, right? So let's talk about transport layer, right? By the way, TCP, this is this is like a TCP part 1. I'll go through the basic part of the TCP, right? Because TCP alone is a huge topic. So we have OSI model, right? And then we have a TCP/IP model, right? So first you need to understand this TCP model and OSI model and TCP/IP model, right? Let's see. So I want you to memorize, right? I want you to memorize this layer, OSI layer, right? Okay, so in OSI, right? So by the way, this is OSI model, right? This is OSI model, and then we have layer 1, right? So this is layer 1, and then layer 2, layer 3, layer 4, layer 5, layer 6, and layer 7. This is all the way to layer 7, and layer 7 is application layer, right? And the layer 1 is a physical layer, right? Which is just wire, right? Just like a fiber, cables, cables, and your wire, and etc. Right? That's a physical layer. And then you have what? You have a transport. Above the physical layer, this is layer 2, right? This is layer 2. By the way, this is layer 1, not layer 7. This is layer 1, and this is layer 7. This is layer 7. So sometimes I'll say application layer, or I'll say layer 7. And then we have a presentation layer, right? And then we have session layer. And then we have transport layer. And then we have network layer, and then data link, right? Right. And then we have another model. It's called TCP/IP model, right? So this is a TCP/IP model. And in TCP/IP model, basically this application layer and presentation layer and session layer, right? That lump into a called this application layer, app, right? So this is application layer. And the transport layer is called TCP, or the transport, or the either people call it a transport layer, or we can say this is like TCP, transport control protocol. The network layer, right, is called internet layer, or we call it IP layer, IP, right? So this is IP is again, this network layer is number 3. And then IP layer is a layer number 3, and then transport is number 4, and then transport TCP is also number 4, layer 4, right? And then data link layer is number 2, the same thing, right? The data link layer. And then this is layer number 2, and then we have a physical layer, right? This is layer number 1. So basically the important thing is this. We have a TCP/IP model in IP layer in the TCP/IP model. And you know that the TCP is equivalent to a transport layer in OSI. And then IP is equivalent to the network. The IP layer in TCP IP model is equivalent to a network layer in OSI model. The data link is the same, and there we have a physical layer. By the way, since it's layer 3, right? The IP layer, basically the router, right? Router, it's the one that intensively use the IP layer. So that's why the router is sometimes is called what? Layer 3 device. And the data link layer, right? Data link layer, it's the Ethernet. The Ethernet is mainly used the data link layer. The device, so we know the switch, right? Switch is mainly used Ethernet addresses. So the switch operates on a data link layer, right? The switch. So the switch is sometimes is called what? Layer 2 device, right? And then TCP, right? So and then on the top of IP, there's a TCP layer, right? TCP or the UDP. TCP UDP. TCP/UDP. We'll talk about UDP later, right? So basically, UDP means a user datagram protocol, and the TCP is called what? Transmission. The transmission control protocol, right? So, and the UDP means user datagram protocol. Both protocols, TCP and UDP, is what? Layer 4 protocol. Layer 4, basically. Okay. So this and this I want to memorize, because many questions, when you take, like, for example, Security Plus, Network Plus, and Cisco CCNA, right? Some of the problems, are really based on this OSI model and TCP IP model, right? So I want you to memorize. Okay. So now the transport layer is responsible for creating and maintaining a logical connection. So this is very important. It's not the physical connection, it's a logical connection. So I'll talk more about this later. Why it's called logical connections, right? So I want to. So basically, if you look at the frame, right? We have this data frames and etc. Right? So we have a TCP header right there, right? And we have IP header, and then we have a frame header. And since we are talk right now, the main topic, right? Main topic of today's lecture is the TCP, right? So let's take a look at the TCP header. And I want to look at this TCP header, right? So let's just dissect this TCP header, right? Let's just dissect this TCP header, and I'm going to tell you what you should know about TCP header. I know that not like IP header, as you can see, the TCP header has many different fields, right? So if you look at the TCP header, there's source port, destination port, which is 16-bit each, the sequence number 32-bit, the ACK bit, acknowledgement number, also not the ACK bit, sorry, ACK number. ACK number is 32-bit. And then we have a 6 flag, urgent, I think this is what, ACK push, PSH is push. I think RST is, I think is reset. Or it's not really important. The SYN and FIN, right? We have 6 different flags. There's a window, and then the checksum and etc. Right? So there are many different fields in the TCP header. Whereas, as you can see, the UDP header is very simple, right? And so I'll tell you why UDP header it's a lot, it's only like few fields, right? So it's a lot simpler compared to the TCP header, right? So let's just talk about a TCP header a little bit, right? The things that you should know about the TCP header. Okay, so first, let's say, remember, like if you look at the TCP IP model, right? TCP IP model, we have what? We have a physical layer, and then we have what? We have the Ethernet layer, right? It's data link. This is too thick. So it has a data link layer. Oops, this is too. The data link layer, which is the, what? I said Ethernet layer, right? Ethernet. And then on the top of Ethernet, we have IP, which is layer 3, right? This is layer 3. This is layer 2. And then we have a TCP, right? Which is layer 4. And then we have an application layer, right? So when you're PC, right? You know that, let's say this is, there's a switch, right? There's a switch. So whenever there's a switch, you know that this is what? This is local area network. This is a LAN, right? There's a LAN. This is a local area network. And then there's a pieces is connected here, right? And then, so there's another piece is connected, right? And then there could be another LAN, right? Could be another LAN. And then this LAN is connected through the router, right? So when this, the A, right? This machine A has IP address, let's say 1.1.1.1.1, right? When this guy sends the, let's say some frame, right? It first, okay, let's say A wants to send a some message. Let's say hi, right? Or hello world, whatever. So this is some text message, right? It has to first go through the switch, right? And then switch is actually connected to the router here. So so it has to go through the switch. So first, you know what? I have to use the, let's see. So I have to a little bit. Okay. So A, right? A wants to send this some packet. I mean frame, right? So what it's going to do is that A, right? A first, you need to create a first Ethernet frame, Ethernet header. Right, so since this has to go through this switch, so first put the Ethernet header, right, and then because it has to go through the switch, and switch is a layer 2 device, so this is basically it's for the layer 2 device, for the switch. Okay, and then inside this data, right? Basically that there's Ethernet header and an Ethernet trailer, but let's say we only have Ethernet header. And then this is like a data. So this is like a data path. So the switch, they don't really care, since it's a layer 2 device, it really does not care what's really inside the data. They only look at what? Ethernet header. So this Ethernet header, right, arrives at this router. You know that the router is what? Layer 3 device, right? So inside this data, there is what? There's IP header. This is IP header. And we know that it's in the IP header, two most important field in the IP header is what? Source IP address. Let's say there is a machine. Let's say machine B. This IP address is, let's say, 5.5.5.5, right? So the source IP address is what? 1.1.1.1, and destination IP address is what? 5.5.5.5. So those two important fields in the IP header. So this router, right? Look at the IP header. They don't really care about what's really inside the data, right? They only look at this. Basically, their main concern is look at this IP header and then find out the destination IP address, right? Mainly for this guy. Okay, so he'll look at his routing tables and he forward this packet into this router, right? And then, so this IP header is for what? For the layer 3 device, such as the router, right? So for the router, right? For the router, basically this is the data. So this is the data part for the switch. Now this is a data part for what? This is a data part for the router, right? So basically, when you look at this data part, inside this data part, right? Inside this data part, there is another header called TCP. TCP header. And this TCP header is what? Layer 4, right? So you know that this is layer 2, and then layer 3, IP header, and the TCP header is what? Layer 4. But as you can see, I'll talk more about this later, but as you can see, this router, right? This router is basically does not really need to look at the TCP header because it's simply, this is going to be data field, I mean data, right? So the router only look at what? The router only look at the IP header. So as you can see, both routers, right? They receive the packets, and this guy received the packet. It only look at the what? This IP header, not the TCP header. Okay. So when you look at this TCP header, so TCP header will be examined. Okay. So when first machine A create the message, he will create the message. So this is like workstation, right? So basically your operating system such as a Windows or the Linux, right? Your operating systems, they basically create this IP header and the TCP header. Their network component, right? In their for example Linux kernel or the Windows kernel, it creates the IP header and TCP header, right? So when machine B receives finally through the switch, right? Their switch, and then finally receive this packet. Now this machine B, right? Let's say running on Windows or the Linux. So basically your PC, your home PC, or any workstation. They're running some operating system such as Windows and Linux. Finally, this machine B, this workstation B, will look at both IP and TCP. Okay. So, and that's why TCP is called a end-to-end service, right? I'll talk more about this later, but if you look at the previous slide, the TCP is what? Oops, yeah, the next slide, they say TCP is what? End-to-end service. So what it really means by end-to-end service is that, so this is what? I'm going to use the blue. So basically this is what? This is end device, right? and then this machine B in other local area network is the end device. So that's why only those end device, only this end device are the ones that need to examine the TCP header. Okay, like all the devices in the middle, actually there's internet here, right? There's the internet. There's a lot of switches and routers, basically. So all these routers and then switches in the middle, so there's a path, right? All the devices in the middle, they're never going to examine the TCP header. Only what? Those end device, this machine A and machine B, or your PC A or PC B are the ones that need to examine the TCP header, layer 4 layer, right? And that's why it's called end-to-end service. Okay, so now let's take a look at this TCP header. So TCP header, there is what? There's a source port number and destination port number, and there's sequence number, ACK number, and the couple of flag, right? So when we look at this TCP header, right? Let's just examine this TCP header in detail. So when you look at this TCP header, so let's say this is a TCP header, right? And then we know that this is what? 32 bits. Okay, and then there's what? There's a source port number. There's destination port number. So this is obviously the 16 bits, right? Because everything's a 32-bit, this is just exactly half. And we have called sequence number. And the next one is the ACK number, ACK number, acknowledgement number. And then there is there are some flags. In here, 1, 2, 3, 4, 5 and 6 flag, and each of them is a 1 bit. So this is like 1 bit long, right? And there are 6 flags. There are 6 of them, right? 1, 2, 3, 4, 5, 6. Among 6, I want to memorize the 3 main ones: SYN and ACK. So this is ACK bit, ACK flag, and then FIN. FIN means finish, done, right? I know that there's 3 more, but basically in the TCP header, I want you to memorize only what? 1, 2, 3, 4, 5, 6, 7. 7 of them, okay? And then those are the most important field. For now, just this 7 field in the TCP header. Okay, let me emphasize one more time. Source port number, destination port number, sequence number, acknowledgement number. This is a 32-bit, by the way. It's a huge number. It's a 32-bit. An ACK number, and among 6 flag, I want you to only memorize what? 3 of them, which is SYN, ACK, ACK, and then FIN, the finish, right? So, okay. So let me just end my lecture here, right? I'm going to talk more about TCP in next lecture. Okay, so basically this is a TCP basic part 1.